Okay, this lesson is about directed line segments and modeling. All right, a directed line segment, you know what a line segment is, all right? It's a set of points running between 2 points, but we're giving it a direction. So we're traveling from F to D. And if you have a direction, then one thing we can do is talk about partitioning the line segment in a certain ratio. That means we're going to break it up so that the parts have a certain ratio. And for example, say if I broke the line right here, I want it to be in the ratio of 8 to 5, but I want to start at F and then go to D. So please understand we're going in this direction. So when we say 8 to 5, the 8 has to come first. We need the 8 to be here and then the 5 to be here. So it's sort of backwards from the way it looks, but it's because we're going from F to D. We're going from right to left, 8 to 5. And as you can see, if I split it here, it accomplishes that because over here I have 1, 2, 3, 4, 5 parts. And over here I have 1, 2, 3, 4, 5, 6, 7, 8 parts. So that's what it means to partition this directed line segment in the ratio of 8 to 5. Okay, now I'm going to teach you how to find where to break it. Like I just jumped straight to 1 because I knew that was the answer. All right, and but I'm going to teach you a method for how to figure out where to break it so you can get the right ratio. The first thing I want you to do is when you see the ratio, I want you to turn that into a fraction. Okay, here's what I mean. If you see the ratio 2 to 3, okay, that means one part is 2, the other part is 3, but I need a fraction. So instead of thinking this as of a ratio 2 to 3, I want you to think of it as 2/5. Because I'm getting the 5 from doing the total here, okay? Here's what my thought process is. There are two questions we need to answer. We need to answer the question, how far do we go? That's the first question we're going to answer. How far do we go? And then we have to answer the question, where do we land? All right, and that'll be the final answer. All right, but again, in order to answer the question of how far we go, it's not so useful to have this ratio. It's better to have a fraction. So, for example, let me just give you a couple more examples of turning these ratios into fractions. If I saw a ratio of 3 to 4, that would actually mean I need to go 3/7 of the way, okay? In order to produce this ratio, I need to move 3/7 of the total distance, okay? If I saw a ratio of, let's say, 5 to 6, that would mean I would need to move 5/11 of the way over. All right, so hopefully you can see I'm getting the denominator by adding these up. So getting back to the actual problem that we have, okay, if I want to know how far I'm going to go, I need to turn this into a fraction, and that fraction is going to be 8/13, because 8 plus 5 is 13. All right, so that helps me answer the question of how far do I go, because I need to go 8/13 of the total distance. Okay, that's how far I need to go, 8/13 of the total distance. Now, in this case, because we're talking about whole numbers, I could just sit here and count to find the total distance. I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whoops, 11, 12, 13. That's a total distance of 13. But there's two things. First of all, we're dealing with directed line segments. We have direction. To capture the direction, all right, are we moving 13 to the right or 13 to the left? When we talk about this total distance, I'm going to include the sign, meaning if I want to move to the right, that's going to be a positive sign. If I want to move to the left, that's going to be negative. Okay, that's to capture the direction. It's a directed line segment. Normally we only think of distances as being positive numbers, but we're going to use the signs to help us know whether we're moving to the left or to the right. Now in this case, we're moving from F to D. So we are moving 13 spaces to the left. So is this going to be positive or negative 13? This is going to be a negative 13, all right? We're going to think of this total distance as 13 to the left. That is a negative 13 total motion. Okay, so I'm going to put that negative 13 right here. But then I want to talk about how we can get that number without counting, because sometimes we won't be able to count. What if it's a decimal or a fraction? So here's how you come up with the total distance, including the sign, without counting. We could get that total distance using subtraction. Just take the first number minus the second number. Okay, so we could get this negative 13 by doing negative 4 minus 9. And of course that will give you the negative 13. Okay, so from now on we'll just subtract because sometimes it might be a decimal. Okay, so if we do 8/13 of negative 13, okay, so let me put the negative in there. All right, so 8/13 of negative 13 is negative 8. Okay, now again, this negative 8 is telling me not only how far we go, but it's also giving me the direction. All right, this means that we're going to go, the negative 8 means that we're going to go to the left 8, which makes sense because we're starting from 9 and we're going to the left. Okay, so we're going to move negative 8. So, and that's to the left. So if I start here at 9 and I move negative 8, that would be 1, 2, 3, 4, 5, 6, 7, 8. So that's going to put us here at 1. So that's actually going to answer the question of where do we land. We landed at 1, and that's going to wind up being the final answer because that is the location of this point G. However, again, you see me counting. We're not always going to be able to count. Sometimes these will be decimals and fractions. So we need another way to figure out the location other than counting. Well, all we have to do is take our starting point and add our motion. All right, we just figured out that we're going to move negative 8. So if I start with my 9, all right, which is my starting point, I'm going from F to D, so of course 9 is my starting point. If I just add the motion, which is negative 8, so 9 plus negative 8, which of course is just 9 minus 8, you know that. Then that's going to give us our answer of 1. Okay? So this will be useful for when we have fractions, that if you just take your starting number and your motion, add them together, that will tell you where you land. Now, often in textbooks and in online presentation, this is presented as a formula. So I really broke it down as sort of common sense to show you where it all is coming from. But you will see it as a formula very often. So I want you to understand where the formula is coming from so you can answer questions about the formula. So let's go back through. This will be a good review of what we did. So our first step was we had to take this ratio, and in order to figure out how far we were going to go, we had to turn this ratio into a fraction. Where did I get 8 over 13 from? 8/13? Okay, well, remember I did 8 over 8 plus 5. I added those together. So you'll see this as part of a formula sometimes. Okay, then we were doing the fraction of the whole. Remember, this was the whole distance. Okay, so it turned out to be -13, but remember where this came from. We learned that we could find the distance by simply taking the first number minus the second number. So we just did -4 minus 9. Okay, and that gave us the -8. That told us how far we would go. But then to answer the question, where do we land, we learned that we could just take our starting point and add this number. Okay, so basically, we could have done it the other way around. So we have our -8. If we take that and we add the 9 to it, so basically all this represents the -8, the motion. If we take that motion and then add our starting point, okay, plus our starting point, that will tell us where we're going to land. All right, so we have our fraction of the total, okay, then plus our starting point, and that's going to tell us where we land. So you'll see this written out as a formula. Now you know where all the pieces come from. All right, here's problem number 3. This one will be a little bit more complicated because instead of just having a number line, we have a coordinate plane. All right, we have x values and y values that we have to deal with. Notice the direction. We're going from J to K. So here's what I recommend doing. And I've covered up the answers here so we can let it be a surprise. What I would like to do is I'm going to take this and I'm going to basically turn it into 2 number lines. Okay, I'm going to do one number line for the x's, and I'm going to do another number line for the y's. Okay, so for right now, focus on the x's. Okay, I have -6 and I have 8. Okay, so here I'm going to make a number line just for the x's. Okay, so here's my number line for the x's. So it needs to go from -6 to 8. So here I go. Okay, so I'm going from -6 to 8. Okay, now the first thing I'm going to do is I'm going to look at this ratio, and like I said on the previous problem, I need to turn this into a fraction because I'm answering 2 questions. How far do we go? And where do we land? How far do we go and where do we land? So if I want the ratio 2 to 5, then that means I'm going to go 2/7. Remember, I add these up. I'm going to go 2/7 of the whole distance. Okay, so I know, looking at this, I need to go 2/7 of the total distance. Okay? Now, let's see. Remember, I'm going from J to K, and this is J, and this is K. So I'm going from J to K. All right, it's very important when I calculate my total distance, I want it to have the correct sign. Positive if I'm going to the right, negative if I'm going to the left. And one way to guarantee that is make sure you do the second one minus the first one. So I'm going to be careful to do 8 minus -6. All right, look at your direction. I'm going from J to K. So I'm going to do the end minus the beginning every single time. So 8 minus negative 6. Okay, 8 minus negative 6, I hope you understand, is the same thing as 8 plus 6, right? This is the same thing as 8 plus 6, which is 14. Okay, so I'm answering the question, how far do we go? How far do we go? I'm going to go 2/7 of the total distance of 14. Okay, now I know that this is going to be 4. Okay, but if you could not do that in your head, you could use a calculator and do 2/7 of 14. And so you see that's going to be 4. Now the way I did it in my head, I saw that 7 goes into 14 twice. 2 times 2 is 4. Alright, so this tells me how far we're going to go. It even tells me that I'm going to the right because it's positive. Okay, now we need to answer the second question. Where do we land? Where do we land? So to figure out where we land, all I have to do is I need to take this motion of 4 and I need to add my starting point. Okay, my starting point is negative 6, so I need to take my motion of 4, I'm going 4 to the right, and take that motion and add it with my starting point of negative 6. Okay, so that's going to give me negative 2. So that tells me, well, that tells me the x value where I'm going to land. Okay, so let's see. So that tells me that the x value is negative 2. I still need to find the y value. So I need to do that all over again for the y values. Okay, I think I'll do the y over here in this space. Alright, since they're y values, I'm going to go ahead and do it vertically. Okay, so notice the y values are negative 2 and negative 9. Okay, so I'm going to make my little number line vertical now. Alright, see I have negative 2 high and the negative 9 is low. So here's my negative 2. You know what, maybe I'll put it on this side. Here's my negative 2 and here's my negative 9. And I'm going from J to K. So this is J and this is K. And I'm moving in this direction from J to K. Alright, so I'm answering two questions. How far do I go and where do I land? To answer the first question, how far do I go, I need to go, again, 2/7 of the total. I'm using my fraction, 2/7 of the total. How do I find the total? You do the second one minus the first one. So we're going to do negative 9 minus negative 2. Negative 9 minus negative 2. Okay, now if you were going to do this in your head, you would hopefully recognize that this is the same thing as negative 9 plus 2, and that's going to be negative 7. If you have any trouble with signs and things like that, then I encourage you to use a calculator when you need to. Alright, so for example, you could sit here and go negative 9 minus negative 2. Okay, and that's going to give you that negative 7 if you need it. Alright, so how far do we go? 2/7 of the total distance. Okay, and what is that? Well, I know that this is going to come out to be negative 2. Okay, and again, if you need to, you can put that in your calculator, but I see that the 7s are going to cancel out. Alright, so that gives me negative 2. Now, to figure out where I land, you take that negative 2 that you just found and you add your starting number. Okay, so this could get confusing because it involves negative 2 twice. But this is the negative 2 that we just found. And now I'm going to take this negative 2 and I'm going to add it on. So I have negative 2 plus negative 2. So that's going to give me negative 4. Okay, so this, all right, remember we're doing the y values right now. So this tells me that the y value is going to equal negative 4. Okay, so we have an x value of negative 2 and a y value of negative 4. If you put those together, then that's going to give me the point negative 2 comma negative 4. Okay, that should be the partition point. Okay, so that would be negative 2, negative 4. That's the spot right here. Now, I think I've done more than they asked me for because they said, what is the x-coordinate of the point? So, in retrospect, we were actually done when we got the negative 2. All right, but this was good because on future problems, on many problems, they're going to ask you for the x and the y, not just the x. But let's reveal and see how we did. Yes, negative 2 is the answer there. But we also got, as a bonus, I showed you how to find the y value as well. All right, this is very complicated, so I think we'll need more practice. Okay, time for problem number 5. Now this time I'm noticing that they're only asking me for the y coordinate. I am going to go ahead and find the x and the y because this is good practice. This is the third problem I've done, so I'm going to try to do this one a little bit faster. I hope that's okay. So over here I'm going to do the x value. So let me leave space. So x equals, that's what I'm going to find over here. So here's how we'll do the x values. Let's look at the x coordinates, the beginning and the end. So the x coordinates are the negative 8 and the negative 3. Okay, so here's my negative 8 and my negative 3. Now the order matters. We're going, okay, so this is K, and this is J. Now we're going from J to K, so I'm going in this direction. Wait, one of these, this is a negative 3. Why didn't you guys tell me? You just sat there and let me put negative 8? Make me look like a fool. Okay, so we're going from negative 3 to negative 8. Okay, so the first thing we always do is take this ratio and convert it to a fraction so we can figure out how far we need to go. As a fraction, this is going to become 2/5 because I added those two numbers together for the denominator. That tells me that I need to go 2/5 of the way over. Okay, so I need to calculate how far that really is. So I know that I'm going to do 2/5 okay, of the total distance. Okay, now off to the side somewhere I'm going to do this calculation. For the distance, I'm always going to do the second number minus the first number. Okay, I'm paying attention to the direction here. Okay, so because I'm going towards K, I'm going to do negative 8 minus negative 3 in that order. Okay, it's got to be the second one minus the first one. You know what, I meant to do that off to the side. So I'm doing negative 8 minus negative 3. And in here I'm just going to put the result. I think that makes it more clear. Now, negative 8 minus negative 3, you know that's the same thing as negative 8 plus 3, right? Okay, minus and negative is addition. So that's going to make negative 5. Okay, it's going to make negative 5. So if you go ahead and do that, 2/5 of negative 5, now I know that that's going to make negative 2 because the 5's cancel out. That's negative 1 times 2 is negative 2. I know this, okay? Now, if you did not know that, you could just put it in your calculator, okay? You could do 2/5 of -5, like that. Okay, and you see it's -2, but work on your skills. So once you have that, what do? You add on the original number, okay, the beginning number. So I'm going to take this -3 and I'm going to add it on. So I'm going to do plus -3. Okay, and that is going to give me the final answer. So that's going to give me -5. Okay, and that is the x-coordinate is -5. So again, just real quick, I made the fraction. I did the fraction of the whole distance, which I got by subtracting the second one minus the first one. And I took that answer, and then I just added on the first number. Okay, and that gives me the coordinates. So let's do that again with the y values. Okay, it's a little bit complicated, so it helps doing all this practice. Alright, so they're y values, so I'm going to do them vertically. Okay, so now we're doing the y values. We have 11 and we have 1. So I'll put 11 up high and I'll put 1 down low. Now this is k up here and this is j down here. I'm going from j to k, so that means I'm going up in terms of the y values. Okay, so what do? Well, once again, I do a fraction of the whole, because I'm asking myself, how far am I going to go? I'm going to go a fraction of the whole, 2/5 of the whole way. Okay, so how far is the whole? Well, inside of here, I need to do the second number minus the first number. So I need to do 11 minus 1. So that's going to be 10, positive 10. Okay, so that is going to give me 5 goes into 10 twice. 2 times 2 is 4, so I know that's going to give me 4. If you need to put that in your calculator and get 4, put it in your calculator. Okay, so what do I do with that? Well, I take that 4 and I add the original number. Okay, the beginning number. I'm going from j to k, so that means I'm going to add the 1. Okay, so that is going to give me 5. So I was finding the y value, so that tells me that the y value is going to be 5. Now, if I needed to write all this as an ordered pair, okay, the point that partitions this would be the point -5, 5. Let's check it out. Okay, -5, 5 would be right here. This is the point that would partition this. I want the ratio of 2 to 3. So this would be the ratio of this to this would be 2 to 3. See how this is shorter and this is longer? These lengths would have the ratio of 2 to 3. Okay, but anyway, that's all extra because all they really wanted was the y value. Okay, so we correctly found that the y value is 5. Alright, number 7 is an easier type of question. Point P partitions the directed line segment from A to B in the ratio of 3 to 4. Will it be closer to A or B, and why? Well, if it's going to be 3 to 4, to make that happen, you could imagine that this had length 3 and this had length 4. Now it doesn't have to be lengths 3 and 4, but this would be one way to partition so that the ratios would be 3 to 4 from A to B. So obviously if this had length 3 and this had length 4, then it's going to be closer to A. Alright, because of the 3 is smaller than 4. hold on, I'm trying to do a highlighter thing. It's going to be closer to A. Now, we have to be a little bit more, I don't know, mathematical when we talk about y. So here's what we can say about y. Remember how in the previous problems I always would take this ratio and turn it into a fraction so we could talk about what fraction of the way we're going to travel. And the way we would do that is we would look at this ratio and think, okay, 3 to 4, that means we need to go 3/7 of the total distance. All right, I added those together to make the 7. So the question is 3/7 more or less than halfway? Well, we know that halfway is 50% of the way, right? We know that halfway, another way to look at it as 0.5, okay, as a fraction. All right, 1/2 is 0.5. So if we convert this to a decimal, it'll make it easier to see whether or not this is more or less than halfway. So let's do that. So if we do 3 over 7, or 3 divided by 7, turn it into a decimal, that's 0.42. Okay? All right, 0.4, you know, so you saw that decimal was like, this was approximately 0.42. You know, that means we're going to go 42% of the way. All right, 50% is halfway, 0.5. All right, 42% is less than halfway. So again, that tells you that if we're going less than halfway, then that means we're going to be closer to A. Okay, 42% of the way. Okay, 3/7 of the way. So P will be closer to A because it will be 3/7 of the distance from A to B. That's what we're looking for. All right, more practice of really the same stuff we've been doing. So if you already feel like you know how to do it, don't feel like you have to watch this whole thing. You should be able to do this one by yourself at this point. There's one small twist here. Well, it's actually, they did us a favor. They just gave us the fraction immediately. Instead of giving us, oh, the ratio is 3 to 2, they went ahead and just told us straight out that we're going to go 3/5 of the way. Okay, so that part's already been done for us. So now let's go ahead and get started. This is problem number 9. So I like to do the x's and y's separately. So first I'm going to do the x's over here. Okay, so here's my x values. Okay, so I'm going from I've got -40 and I've got 160. Those are my x values. And this is j and this is k. And we're going from k to j. So I'm going in this direction. Okay, so keep that in mind. So I need to go 3/5 of the distance. So I need to go 3/5 of the distance. Okay, now how do I calculate the distance? All right, they're kind enough to have these little formulas around to remind us that we're going to do the second one minus the first one. Okay, in this case that's j minus k, because j is where we're headed. So we're going to do -40 minus 160. Okay, if they print the formula right there for you, use it. Okay, the second one minus the first one, -40 minus 160. So that's going to be -200. Okay, that's going to tell us how far we're going to go. So I could probably do this in my head, but let's go ahead and use a calculator. So 3/5 of -200. Okay, I meant to put that in parentheses, but it's -120. All right, so that's giving us negative 120. So what I need to do now, and again, the formula is reminding us that we're going to add the first x value, okay, which in this case is 160. We're going to add that on. So that's what I'm going to do. All right, I'm going to add 160. And that's going to give us the final answer. Okay, so negative 120 plus 160, that's going to be positive 40. Okay, now let's do the same thing with the y values. Okay, I'll do the y values over here. All right, I have 120 at the top, and I have 80 at the bottom. Those are my y values. And of course, up high I have k, and down low I have j. And I'm going from k to j. So I'm going down like that. Okay, so I need to do 3/5 of the total distance. All right, again, to get the total distance, I do the second one minus the first one. That's what this part of the formula is saying, second minus first. So I always do that off to the side. Okay, so I'm doing 80 minus 120. Okay, 80 minus 120. All right, that's going to be negative 40. Okay, now I know that's going to be negative 24, but you might need a calculator. So 3/5 of negative 40. Okay, that's negative 24. All right, so I got negative 24. And now what I need to do is add the first y value. Okay, so in this case, the first y value, I'm going from k to j. So the first y value is the 120. So that's what I'm about to add right now. So I'm going to go plus, whoops, I meant to put it up here next to the 24. So I'm going to go plus 120. Okay, let me erase this little mark. All right, and that is going to give me the final answer. And remember, now over here we're finding the y value. So negative 24 plus 120, that's going to give me the y value. All right, that's 96. Okay, that means you put it all together, and the coordinates of the point of partition should be 40, 96. Okay, so that should be our final answer. Now let's reveal and see how we did. 40, 96. All right, number 11 was the exact same thing as like 3 previous problems, so I decided to skip it. There's no point in doing another problem that was just exactly the same thing. But number 13 is a little bit different, so let's talk about that. The midpoint of a line segment partitions a line into a segment, partitions the line segment into a ratio of what to what? Well, it's a midpoint. Okay, so that means it's going to be halfway. So, you know, the numbers would have to be the same, like 3 to 3. okay, or 5 to 5, or 6 to 6. But think about all these fractions, okay? If I do 3 to 3, what does that reduce down to? 5 to 5, what does that reduce down to? 6 over 6. They all reduce down to 1 to 1. All right, all these ratios reduce to 1 to 1. So if it's at the midpoint, they have to be the same on both sides. Okay, so that means it has to be a ratio of 1 to 1. All right, it's the same on both sides, 1 to 1. Okay. All right, this will be the last problem in this tutorial. So I hope this was helpful to you. Working the odds, except for I skipped number 11 because this is getting too long anyway. This is already 40 minutes. Anyway, Miguel and his brother Ario are both standing 3 meters from one side of the 25-meter pool. Okay, so I guess this is the side of the pool right here, but I don't think that matters. Okay, when they decide to race, so they both are standing here. Miguel offers Ario a head start. He says he will start when the ratio of Ari's completed meters to his remaining meters is 1 to 4. Okay, so in other words, again, right away, we'll take that ratio and turn it into a fraction. So he's saying when you are 1/5 of the way. Okay, 1/5 of the total. That's what he's saying. So I got the 5 by adding those up. So fine. He's going to start when it's a ratio of 1 to 4. That's 1/5 of the way. Okay, so how many meters will Ari swim before Miguel starts his race? Well, it's going to be 1/5 of whatever the total is. Now notice they didn't ask us at what marker. They didn't ask us what number will he be when Miguel starts the race. So we're not looking for the final position of Ario. We're just asking how far will he go. So we're not going to do the part like we usually do at the end where we like add on the number and see where we land. No, we're just going to do the part where we figure out 1/5 of the total. That's it. So let's see, well, what's the total? And then we'll do 1/5 of it and we'll be done. Okay, well, remember, an easy way to find the total is to do the second number minus the first number, which is what this means. x2 minus x1, the second number minus the first number. So the total is going to be 25 minus 3. Okay, so obviously that is a distance of 22. So that's the total distance we're talking about, and 1/5 of that, that's how far he's going to go. That's how far Ario gets to go before Miguel starts. So let's see what that is. So 1/5 of 22. Okay, we want a decimal here, so I'm going to toggle it, 4.4. So he's going to go 4.4 meters. Is that what we're talking about? Yeah. He's going to go 4.4 meters before Miguel starts. All right, now of course, so that's the answer. That's the answer. If we wanted to find out exactly where that would be, of course, we would just take the starting point of 3 and then we would add 4.4 meters to that. So that would be 7.4, but that's not the answer. They just wanted to know how far he would go. The position, he would be right here. He would be about here, 7.4, and then Miguel would take off. But he will go 4.4 meters. That's how much of a head start he gets.